the rule, you must tell me, is that a high estimate or a low estimate? Well, since you took them both up, that is a high estimate. There you go, sweet, right? So if you want to be conservative, you're like, I don't know, man, they each weigh this much, and they're all going to be sitting in this many chairs. How much total weight we're talking about? Well, I can just be conservative and say 20,000 pounds or whatever, right? You guys see what I'm saying? I mean, I can be conservative that way, but I know it's a high estimate. Do any of you guys have jobs, like a lot of construction work and stuff like that, where you have to estimate stuff? Anybody ever had that experience? Yes.
I was a cook. I mean, we do conversions all the time.
Yeah, and then you don't want to get, you don't have to get like 1.87 cups of flour. You're like, well, just freaking get close, right? Pinch of this and that.
Yeah.
So estimation, construction works a lot too, because you got to get materials out. You say, well, it's about this big, we need this much, okay, we need about this much wood, right? Because you don't want to, you don't have a calculator, you got to tell them right then, okay, just this about this much wood. Stuff like that where you're somewhere you can't have a calculator to get the answer. So you kind of see what's going on here. Like, here's one that always trips people up. If I had, what do you have, Jeff? I don't know. 89 point, no, let me do it this way, sorry. 90.32 divided by 0.091. Now be careful now. If you make the bottom one, do you see how that's a huge step? 1 is not close to this. You make it 0.1. Isn't this 0.091? Isn't that close to 0.100?
Yeah.
If you make it 1, you took a big old step. Way too big of a step to take, right? So if you make this top, you're obviously going to make the top 90. So you actually went down a little bit on the top. We're going to go up a little bit on the bottom because it's so close to 0.1. Now I know some of you guys are going to be like, well, Jeff, man, you divide by a freaking decimal. I don't like that. Is that what's going on? Or?
Because I thought it had to be like a full number on the bottom. Like
When we do that, can't we move the decimal on top and bottom?
Now here, exactly.
a decimal.
I can multiply top and bottom of a fraction by anything I want to, except 0, right? So if I multiply by 10, what happens? Doesn't this just move over 1? And what happens up here?
900.
So 900 divided by 1 is 900. So dividing by decimals is not a problem. If I had, for example, all right, first off, does everybody understand the breaking the rule here? They're both so close, but they didn't both go the same way. Now, before I get too far, is that a high or a low estimate? Who can tell?
Shouldn't it go the other way? I don't understand. 900.
So the rule is, when a divide, they should both go the same way. We broke the rule here, didn't we?
Yes.
Because that was so close to 90 and that was so close to 0.1.
Okay.
Is it a high or a low estimate? I made the top smaller and the bottom bigger, so I'm dividing less by more, so it's a low estimate.
Your multiplication just makes me up because it would be times 10 to both of them.
Yes, exactly. Sorry. Yeah. Cool. Or just move the decimal over. How are you guys doing? A little bit. Okay. That's fine. We're just not getting into this, so it's okay to be lost a little bit.
If the denominator were the number that were larger, and then the numerator was smaller, would that then be a high estimate?
Exactly. If I made the top bigger and the bottom smaller, it'd be a high estimate. Because if I divide more by less, that's bigger than what it. Here I'm dividing less by more, so I end up with less at the end. Right? Yeah.
Would you do the same for a percentage and then a number? So like say
Exactly. You could do like.
9% and then 2,164.
Do it again.
9% and 2,164.
2,000.
164.
Yeah. So in this one, what does of mean? People seem to know this less and less. What does of mean when you talk about percentages? Multiply. Definitely means multiplication, right? 50% of 100 is 50 because you multiply 0.5 times 100. Of means multiply. So really, to write this in math, 0.09 times. Now this, we can follow the rule perfectly here, right? Because if I take this guy, how do I run around this guy? Up. So round him up. 0.1. I'm going to round this guy down. And here's your judgment call. You could either take it to 2,000 or you can go to 2,100. Right, it's up to you how big of a step you take. Because either way, that's 0.1. That's easy. So if I go to 2,000, what's the answer? What do you get when you multiply by 0.1? What happens to this? Decimal moves once back, right? 1/10 of this is 200. Cool.
Wait, where'd you move the decimal? Can I write it out if you've done that?
So right here, and now you guys are starting to see why 120 has a prereq of 103.
Why didn't you add, why is it 200 versus 20,000? If you're dividing 0.1 into 2,000.
No. What's the operation here?
We're dividing over here and multiplying over here. So the-
Right here, this is multiplication, right? Cool. Over there, we were dividing. But here, we're multiplying. And again, 0.1, when I multiply by 0.1, that decimal's got to move back once. If I multiply by 0.01, the decimal moves back. Okay. Twice, right? Because what is 0.1 as a fraction? 1/10. So am I not dividing by 10 then? Wouldn't that just kill one of the zeros? Which is the same as just move the decimal back once. So these are the kind of things I really need you to have in your bag of tools, right? We should know what happens when I multiply by decimals or divide by decimals, right? You always have the calculator. I don't know if you're doing this step in your calculator or not. You certainly could, but you shouldn't kind of know what 0.1 does to things. Multiply by 10 makes it 1 0 bigger. Multiply by 0.1 makes it 1 0 smaller, or 1 decimal back. So that's going to be 200. Okay, cool. So the better you did in your 103 or 110 class, whatever you took before, the better you'll be here, because there are going to be little places like this that rely on you knowing how decimals work and so forth, right? The longer it's been since your last math class, the harder some of the stuff's going to be. All right, so let me give you a couple to try. Call me over if you need some help. Actually, not everybody has a booklet, so I'll write it up on the board. Page 14. Oops, let me do that. Let's see, that should be 7, 10, 17.
Don't we start with number 3?
And
She's giving you random.
Oh.
go back, I'll do number 12 also. So try those out. Call me over if you need some help.
Oh, you can write them
Yeah, you're
Oh,
gonna.
yeah, that's right.
down.
I'm so used to everybody having the book. Okay. So 7.
For number 7, now who put it to 1?
Yeah, if you want to go round this up, you can round this down. Yeah. But 1 is kind of far away, so you want to round that down a decent amount, right? Keep those on track.
I don't see how it's, I mean, I don't see how 1 is far away.
You can break the rules on that one.
Because 0.63 is pretty far away from a whole 1, right? So, let me get you guys, tell me this. Is 50 kind of far away from 100? I mean, you wouldn't really round 50 up to 100. That's a pretty big step, right? But some of you guys might argue with me that 0.5 is not very far away from 1. It actually is just as far away as these two. Now far away here is talking about how big of a relative step did you take, right? I mean, if I go from 50 cents to $1, that's a huge step. So that maybe be too large of a step to make, right?
Yeah.
So these don't have to be perfect. But if you did take this to 1 and you didn't take this round very far, and you check it against what the real answer is, you're going to be off by quite a bit.
So would it be safe to do like 0.5?
If you want to take this one and round it down, then you have to round this one up.
Unless we break the rules, because I mean, it's pretty close to 15, and that would be 750, that'd be a low estimate to that.
Yeah, so you can certainly break the rule as long as you tell me if it's low or high.
Yeah.
So you can really break the rule if you feel comfortable with it. You got to tell me if it's too low or too high. If you're really not sure what the hell's going on, as long as you follow the rules, you'll be okay, right? So in this very first one, if you do round this one,
I put it at 0.5.
so if you round it, yeah, you can make it, one thing you do is make this point 60, and then this has got to go
You can do 16.
up to 16, and that's not too hard to do in the head, hopefully.
Yeah.
16 times 6, really. So that's one way to go about it. And see how taking this down by 3 to 0.60 and then taking this up to 1600, that's about the same relative step on each. But if you take this, if you take this down, one way to do it is to take this to 0.6 times 1600. So I took this one down, and this one went up. Cool.
So I couldn't take it 0.6 to 1500 and be a low estimate?
You could, but there's no reason to break the rule there, right? There's no reason to break the rule. Why not just follow the rule? It doesn't help to break the rule. The other ones we were doing, they were so close to something, I might as well break the rule and do it, right? There's no reason to really break the rule here.
If
Oh,
I,
I see what you're saying.
if I
I
did
break the rule and it's like really close.
if I
Yeah,
did
exactly.
0.60, but I still-
Who did it a different way on this first one? Maybe I heard some people, what did you do, Jenna?
I don't know if it's right, but I rounded it up to 1,
Okay?
and then I made it 1500. Was that bad?
Yeah, that's not enough. That's what I'm saying. This should be, I agree, it should be 1,000. That's still kind of high, but that's a lot closer, right?
If I did 0.60, can I just use 0.60 times 1600, or I have to move the decimals?
Beautiful. 0.6 times 1600. Right?